G. So we have C2O7 2 minus plus H plus S plus goes to SO2 plus OH minus plus 4Cr2O3. So over here this is minus 2, 7 of them, negative 14, 2 left over, negative 12. This is positive 12 on this side, it makes this positive 6. This is positive 1 because it's a simple ion. This is 0 because it's an element. This is minus 2, 2 of them, negative 4, makes sulfur plus 4. This is plus 1, and this is, apologies, I can't, this is negative 2. Over here, minus 2, I have 3 of them, minus 6 in total, which makes each one of these plus 3. So this is my reduction, and this is my, I done that right? Plus 6 to plus 3. Sorry, yeah, 0 to plus 4. So this is my oxidation. So OIR is S is going to SO2 plus 4 electrons. Reduction is Cr2O7 2 minus, and it's a 3 electron difference, goes to Cr2O3. And when I look at these, I'm trying to find a number that these guys have in common. Is it least common multiple is the maths? Yeah, so the number they have in common is 12. So I multiplied this line by 3 and I multiplied this line by 4. So then, oh no, yeah, sorry, go.
So it's Cr2. I thought that means you have to multiply the electrons by 2.
No, so I have no highlighter here easily. There's 2 here, but there's also 2 here. So you've got.
So that I mean I multiply by 4.
No, it means you have to do nothing because you've got. No, you multiply by 2. Does that mean make me wrong now? Good question, Mikey. That has to be a 6. So this is wrong. So that has to be a 6 because, as you say, there are 2 of them and we're only doing it for 1. So good spot. So therefore then this has to be multiplied by 2. So we are going a 3 and a 3 and 12. And
wait, Miss, why are you doing that?
Because when we do the oxidation states, we're doing it for one element. So we're doing for 1 chromium. So chromium plus 6 goes to chromium plus 3 from left side to right side. Because there's...
But they're both Cr2.
But when we do the oxidation states, we do it for 1 element and there's 2 elements here.
But doesn't that have to be the same amount of elements on both sides? Now is there not 4 on one side and 2 on the other?
So it's not, no, we've left the same number of elements currently, so I didn't change that. Let's see, can I find the rubber here? So in our original, this was plus 3 electrons. Because I have 2 of each element, I'm not changing the number of chromiums, I'm changing the number of electrons. Because if I only had 1 chromium, I'd only have a 3 electron change, but I have 2 chromiums, so I have a 6 electron change.
Yeah, but there's 2 on both sides though. Would not be more than just 6.
No, because if there was only 1 on both sides, I'd be adding 3 electrons. But because...
Yeah, but another question is only 2 on one side, and you still multiply by 2.
But you only, when that happens, when you're doing that, so when you are doing that scenario, I'm trying to think of something now that has it. When you are doing that scenario,
there's a Cr2 on one side and then Cr on the other side.
Yeah, so in B, up here in B, that's when you would double your number of electrons, but you would put a 2 here
Oh, okay.
because there's only one chromium on that side. So here you are increasing your number of electrons to 6, which means to make 6 electrons, and
You don't put any whole numbers in
Nope,
front of the CR and the 2 CRs in.
no,
Okay.
not in front of that one.
Okay.
So we are multiplying the top line by 3 and the bottom line by 2. So 2, this turns into 12, this turns into 2, and these cancel each other out. So I am now going to just rewrite up here it with the fact that this is now a 2 plus H plus 3S goes to 3SO2 plus 2CR. I'm just going to delete my oxidation numbers from down here. Okay, so we now have to count up our oxygens. We always do oxygen first. So on this side I have 2 by 7 oxygen, so I have 14 O's here. On this side I have 3 2's are 6 O's here, and I have 2 3's are 6 O's here. So I have a deficit on this side of 2 oxygen, so I put a 2 here for this. And now I count up my protons. On this side I have 2 protons, so this side I will have 2 protons. So I apologize for that. Did that change again? I won't do it here, I have to do it out and draw. So 2Cr2O7 2 minus plus 10H plus plus 2H plus 3S plus goes to 3SO2 plus 2OH plus 2Cr2O3. So the other one you wanted to see was F.
Miss,
Yeah.
is it not 4Cr2O3 on the
Ignore
other side?
on this side, no.
So that doesn't get carried over.
What? No, it does get carried over. So when we wrote the RDL line, originally it was Cr2O7 2 minus plus 3 electrons goes to Cr2O3, and I have 2 chromiums worth of stuff, so
Yeah.
therefore my electron change is 6 electrons. So I don't have to change the whole number here because I have the same number of chromiums, I just have to change the electrons.
Oh, okay.
And then I'm multiplying this line by 2 so that I can have 12 electrons on both lines, and that's where the 2 here and the 2 here then come from.
Okay.
Okay?
F, Mr. F.
Yep. So F is MnO4 minus plus I minus plus H plus goes to Mn2 plus H2O plus I2. So minus 4 of, or minus 2, 4 of them minus 8. I need a 1 left over. Negative 7 makes manganese here positive 7. This is a simple ion, minus 1, plus 1. This is a simple ion, plus 2. This is minus 2 and makes this plus 1, and iodine is an element 0. So I'm going from plus 7 to plus 2. This is my red. And I'm going from minus 1 to 0. This is my ox. So OIR is going to be I minus goes to I2 plus 1 electron. But I have 2 iodines here, so I need to put 2 iodines here, and I need to change this to 2. My RDL line is MnO4 minus. I have a plus 5 electron change, goes to Mn2 plus. Same number of Mn's, so I don't have to do anything. So my number that relates 2 and 5 is multiplied by 10. So I multiply the top line by 5, multiply my bottom line by 2. So I now have 10 I's here. I now have 5 I2s, and I turn this into 10 electrons. Down here I have 2 MnO4. I turn this into 10 electrons, and I have 2 Mn plus 2 here. These guys cancel each other out, so it is correct. So I rewrite up here to match 2, apologies, 10, 2, 5. I'm just going to erase some of this so I can write underneath. So I now count up my O's because it's easier to add O's than it is to add anything else. I have 2 4s are 8 O's here on this side, so I put an 8 in front of my water. I then count up my H's. I have 16 H's here, so I put a 16 in front of this. Does that help you, Mikey?
Yeah, I forgot you have to double it when it's I2.
Yeah.
Try to do another action. Sorry.
It's alright. Okay, so I am here. If you require help, I'm gonna pause this and I'm gonna fix this.
Miss, what questions are we doing?
So, oh sorry, did I put it on the wrong share. So in your chemistry live workbook, 14.4.
Miss, do you mean 14.14?
14.14, yeah.
Miss, are we not supposed to do G?
No, don't do G. It's never going to come up in Leaving Cert, and it's...
Can you do them?
You can, if you want to do it, absolutely.
Yeah, because I started it, but it doesn't look like it worked. Because you have two different numbers for the same thing.
So the issue is that you have I2 in both your oxidation and your reduction line, so you kind of get sharing of electrons between both lines.
All right.
Yeah, so
Okay.
I was even looking at my version of it this morning. My husband and I, we both had a go at it, and I would debate that we're still wrong.
Okay.
Where is my version of it? Is it E or is it not a F? It is G. You're ending up sharing your electrons, and I still don't think we're right. I'll show you my screen, and I still don't think we're right because it doesn't quite work out. So you kind of end up sharing the electrons between everything. So technically you have 3 I2s when you're finished, and you're sharing your electrons between it. But technically this part, it doesn't actually make sense because you don't have a half over here. So I would debate that my husband and I are still wrong on it.
Okay.
So
Thanks.
yeah, that's why I don't have confidence in it.
So you say that won't come up?
No, and the version that does come up is a simpler. It's much easier to figure, but not that this is Declan Kennedy being a smartass, which he has wanted to do occasionally. Jim, if something like that does come up, then that is one where you can solve it literally by just balancing the.
Okay.
Yeah, usually that is the way. If it was to come up, she will give one that has that option, so that you can solve it just by balancing, not with redox numbers.
Miss, could you go through H, please?
Sure. Just give me a second. H. Let's see. So will you call it out to me, Jim?
S02, S2O3 2 minus.
Hold on, give me 1 second. So S2,
O3,
yeah,
2 minus, plus I2 gives I minus plus S4, O6, 2 minus.
okay, so we have minus 2, this is a plus 2, a 0, minus 1, minus 2, this is plus 2.5. We're happy with that part?
Yeah.
So this is the ox and this is the red. So OIR S2O3 2 minus is going to S4O6 2 minus plus a half an electron. We then have RDL is going I2 plus 1 electron goes to I minus. So things that we need to look at are the fact that this half electron over here is for conversion of one S, is for oxidation of S on the left to S on the right. I have 2 here and I have 4 here. So first thing I need to do is I need to make sure that this is 4 S's on both sides. Happy with that?
Yeah.
And because I have 4 S's and each S is worth a half an electron, I turn this into 2 electrons. Does that make sense? So it's
Why is it each S is worth half an electron, not that S2 is worth half an electron?
because when we do the oxidation state, when we worked it out, what's in the boxes up here are for 1s, because like think about what we did. We said oxygen was -2, I had 3 of them -6, I need 2 left over -4. It meant everything on the right hand side was +4. It meant 1s was worth +2. We work out the oxidation state for one equivalent of one element. So
Okay.
here this is for 1s, but this is for 4s.
I thought if you doubled the amount of S's, you'd double the amount of electrons.
Okay, so this is a weird one, because usually in the reduction line that is the case. So here we have this I2 here, which we have to take into account. So I would automatically put 2 here, so I now have 2 I's, but each I, the change in the reduction, is worth only 1 electron each, so that's why I double. So it just happens to be with the thiosulfate that there's multiple S's involved.
Okay.
So that is the weird one, and you'll see in the homework it could possibly even be this one again. I don't think it is, but there in the homework list it says weird one, and it's weird because it's got this row in it. Okay, so then after that it's done, it's balanced.
Yeah.
So technically this is one you can do without oxidation states, if you just look at it from in terms of what's there. You could just do it without ever going near it. So usually it's when there's water and H pluses and OH minuses, that's a definite, you have to do it via oxidation numbers. But when there's not, you can usually get away with just balancing. But it's a good lesson to do, because otherwise you'd never see this.
Yeah.
Okay,
Thanks.
thank you.
Miss, could you go back to the page questions? I don't have the book.
Did I change my share?
I can't see it.
Okay, hold on. Slide, current. Resume. Is that better?
Thanks.
Miss, can you do D, please?
I can. Will you just give me a second and now call it out to me? Hold on. Insert new slide. Okay, call it out to me.
Cu plus HNO3 plus H plus goes to Cu2 plus NO2 plus H2O.
Okay, so 0 minus 2 plus 1 plus 5 plus 1 plus 2 minus 2 plus 4 and minus 2 plus 1. Happy with that?
Yep.
So 0, this is my ox, and this is my red. So I'm going Cu goes to Cu2 plus plus 2E minus. I'm going HNO3 plus 1 electron is going to NO2. I am going to multiply this line by 2, so that becomes 2, 2, and a 2. So these guys cancel out. So then I rewrite. So Cu plus 2HNO3 plus H plus goes to Cu2 plus 2NO2 plus H2O. So I am now looking at my O's. So on this side I have 2, I have 6 oxygen. This side I have 4 oxygen. So I put a 4 here, and 4 2s are 8. Because I have 8.
Do you not need to put a 2 there
A 2 where?
in front of the H2O?
So no, because this 2 goes with the H's. So I have 4 oxygen. Oh, sorry, apologies. Did I do that? And I could have possibly done it when I did the working out. No. Okay, so we had plus H2O. We've said, so there's 2 here, 4 here. Is that what I did in the answers? Did I do the answers wrong? What number are we doing? Why did I put that in? So we have a look. It's too fast. I made a mistake here, so I apologize.
Thank you.
Yeah. Okay, I will repair that. So 2422. Leave that there. Repair it here. Discard. Okay.
Miss, do you know for question B,
Okay,
is that
give me one.
is SO4 and SO3, is that meant to be 2 minus?
In the question,
Yeah.
they are both 2 negative, yeah.
Oh.
So I will put the solutions for these, I will attach them to the homework assignment for you. And have a look at the SEC questions. And we see each other on Friday morning. And if you're okay with it, we'll start the theory for the titrations. Is that okay? I will take